Hi everyone, my name is Mike LePage, and this is going to be a quick video tutorial on our Exodus Pathfinder project, which you can find on our website here and by clicking through into the web app here. So this takes a few seconds to download and requires you to click through to this bit. So this is the Exodus Pathfinder project, and the aim is to allow you to plot your solar system voyage using real data. So this is over 10,000 asteroids currently from the NASA JPL Small Bodies database. Down here we've got some high scores, which I'll mention in a bit. But to start with, to get straight into the simulation, you can choose your start time here with the arrow keys. I've just got a little overhead camera so you can see what I'm doing with my hands. And then once you've chosen a start time, you can press enter to start. So there's a bunch of stuff going on here. You can see I'm at Earth and I've got this 3D grid thing happening, kind of like the lines of latitude and longitude you'd find on a world map. And that's completely intentional. The aim is to make this a much more intuitive interface for navigating around the solar system. Now, I'm going to go through a few things in this video tutorial, but the thing to know is that you can press H to switch through the head-up display, and here we've got a little guide for all the shortcuts that you can use the keyboard for. And so I can press that again to get a minimal display here if I want. You can turn the grid on and off, turn the names of the planets on and off. But yeah, so another thing, shortcuts for zooms, 1, 2, and 3. So 3 is the furthest zoomed out. And here we've got Earth and Mars. I can highlight various orbits of various bodies by clicking on them, and it just holds on to the most recent 3 orbits. So, okay, maybe let's go to, what's this? This is Juno. Okay, that's got a bit of an inclination. It might be hard to get to. What's this one? Parthenope. There you can press spacebar to get in trajectory mode. So a couple of things come up here on the lower right. You can see it records what the transit time is and the total delta V required. So if you actually look, so I can zoom in. If you actually look above each of these nodes, 2036 to .24 to 2037, and that's the starting delta V of 8.16 at the start node and 8.275 at the end. And using the AWSD keys, I can adjust where these nodes go. So A and D are for the starting node here, and W and S are for the finishing node. And you'll notice if I take these two nodes opposite the sun, you get this effect where this is where Earth's going to be at 2026 and where Parthenope's going to be at that time. The trajectory between any of these two spots is itself an orbit around the sun. Okay, so let me just choose, say that, and at this point I can press enter, and you can see I've actually, this dot indicates where my ship is, and I might go back out to the zoom out thing. Now, another thing you can do is press pause to start and stop the runtime, and these brackets, right bracket speed things up, left bracket slow things down. So I'm going to speed things up, and there are still a few bugs, so I tend to slow it down just before it gets to its final destination, because that's one of the more common bugs that I haven't solved yet. And now here we are at the asteroid Parthenope. So I can deselect Juno, Flora. Don't need to have them up now. I'll start with the lower left corner. Tell we're currently at this asteroid called 11 Parthenope. We've got a time here. This is the year 2038, 60. And if I zoom out, this is where all these bodies are at that time. So it's real data taken from NASA JPL. So we've got a recording here of the ambient galactic cosmic rays that are being received, what shielding level we're getting, and then how many millisieverts per day we're receiving. So we're able, during the course of this game, to tally up how many millisieverts, how much radiation the crew will have received during the course of this mission. And because of that, that also means we can do a simple model for crew survival. I could go back to Earth at this point, but I want to also show you the search function. So I've shown you the spacebar gives us the trajectory mode. Sometimes with trajectory mode, you need to toggle the orbits on and off. That's just so that we can get a representation, an accurate representation of where those bodies are going to be. But maybe we want to go to more than just these 28 or so bodies that are automatically in the game. But if we want to go to search mode, we have to make sure that the trajectory mode is off. And then I can press tilde to get a search. So there are two options for search here, by name or by landline. So I'll explain what that is in a bit. But if I want to look up a body by number, so maybe Eros was an asteroid in the Expanse. That was an object. So if I tab through, I can look, or shift tab, I can look at where these objects are. If I type in another number, I can tab through and see the orbits for where all these bodies are. If I want to add that to the group, I can press enter. So that's now pressing enter adds it to the list of bodies that are being kept track of in the game. So actually I can get out of that and I can plot us another trajectory. Now you'll notice that some of these delta V's can actually become quite high, more than we have capacity in the ship. So what I've done with the game is that you can actually go quite high with delta V. Your scoring takes a penalty when it's calculated at the end. Okay, so I could take that trajectory through to 103 Hera, but I want to show you a different way to search. Now, I've already shown you by pressing the tilde key this name search here, but instead we can also search by landline. So this word landline I've made up is a combination of LAN, which is longitude of the ascending node. That is where each one of these orbits, where does it cross the ecliptic plane as defined by Earth's orbit? And on the y-axis here, we've got the inclination. So the really nice thing about filtering things by longitude of ascending node and inclination is that you know that all of these asteroids are going to be in the same plane. And by adjusting the cursor in the upper right box with the WASD keys, we can make sure that that plane is close to the one of the asteroid that we're already on. And so this is quite a neat way, I think, to search bodies in the solar system, because it means you can minimize the delta V you use. Just like with the previous one, I can hover my mouse over any one of these bodies, and if I click on it, I'll get details about it, like how big it is and what spectral type it is. And if I find one that I can pronounce and I want to add to the thing, here's 8282 DELP, and I can just press enter and add that to the list of bodies. Now, if I don't need to go to Hera anymore, if I want to go to DELP, then I can't go into trajectory mode while search mode is on, so I tilde to get out of that, and now I can have a new body to calculate. Because this is opposite side of the solar system to me, it's a very steep elliptical trajectory, but look, I'll do that anyway. Here we are now at Delp, and the one thing I want to finish off with for this short tutorial is the high score system. So in order to get a high score, to list in the high scores, we have to go back to Earth. And so from here, we'll just calculate a trajectory back to Earth. And you'll see that the times get longer as they go from one side of the solar system to the other, but the delta V also gets smaller, as in a Hohmann transfer. And so if I choose that trajectory to get back to Earth, I can go back from this place and catch up to Earth as it goes around the sun. So here I've got the score here, 1517, based on these shelters that I created at Parthenope and at 8282 Delp. And if I quit out of the game at this point and log the score, I can press Shift Q and I get a recording of my ship's log. So leaving Earth to Parthenope at these times with these delta V's, leaving from Parthenope to Delp at these times with these delta V's, and then returning to Earth with these delta V's. I get a little bonus for error braking at Earth, and that gives me a final score which is based on my survival model, how many of my crew survived. So I'm expecting 84% after this 13-year journey. And also my use of fuel was not very efficient. So the crew survival multiplied by the sum of the shelter scores divided by the sum of the excess fuel that I used gives me that score of 1516. So I'll add in my high score, and that log is recorded to the online database. I want to do some meta-analysis on all the entries that will come in for that in the future. And then I can go back to the main score and see, here's my score that I logged on, we're currently in 2024 59. And yeah, there's my score there. Now I've just divided these, rather than doing a daily period, I'm doing a 100th of a year period to keep in keeping with the time scale. But you can see down here that the next refresh will be on August 7th in a couple of days, as of when I'm recording this. So that's been my short summary. I'm sure I'll do more on this in the future, including how we're calculating the solar cycle and how that influences the amount of radiation we're receiving, and a number of other small points that I can elaborate on in future when people are interested. So my name's Mike LePage. This is the Exodus Pathfinder Project. Thanks for watching.